what's happening in this number? The numbers are right, but it's well, how much are they going up by? Oh, that first one should have been a 1.
Oh, that's why.
Yeah. Okay. So, what's the number pattern? What's happening? Every other number. Okay. So every odd number, something like that. Now, maybe I wanted to do something. What if I had a number pattern that looked like this? Or not a number pattern, but a letter pattern. Red, blue, red, R, B, B, R. What comes? Who can tell me what goes in the next 3 places? What goes in the next 3 places?
B, B, B?
What?
R. B, B, B.
Catherine. Yes. Okay. What goes in here? It's B, B, B. Okay. What you just did, and what's pattern, Catherine? Right. Okay. Each B you add. So anytime you look for a pattern in numbers, it's called, what you're using is something called inductive reasoning. And it's just, that's the vocabulary, okay? Inductive reasoning is the process of making a conclusion, making conclusions that says conclusion based on patterns. So we do this with patterns. We do this in math, but we also do this in real life. For instance, maybe you go, it's the first time you ever go into use a certain faucet, okay? And you turn the faucet to the right, and it comes out cold. And then you turn the faucet to the left, and it comes out hot. And then you turn it in the middle and it comes out medium. And then you try it again. If I want cold water, which way should I turn it? Right. Okay, or maybe you're driving and you move to England and you are driving down the right side of the road and you start crashing into people. Okay, how come? Yeah, because you recognize that all the people are driving on the left side. So you say, in England they drive on the left side of the road, not on the right side of the road. Right? So the steering wheels are all messed up. All right. So anyway, inductive reasoning is making conclusions based on patterns. We're mostly going to do this mathematically. Okay, so let's do a couple here, mathematical ones. 2, 4, 6, 8. What comes next? Raise your hands. What comes next, Lizzie?
10, 12.
No.
Wait, what?
10, 12, and 14. No, it should be who do we appreciate? Would it be? 2, 4, 6, 8. Who do we? No, I'm just kidding. Okay. She's right. 10, 12, and 14. Right? And one way you can see how these patterns are changing is by, what's the pattern, Lizzie?
It goes up by 2.
It's going up by 2s each time. Or multiples of 2. Very nice. Now, not all number patterns go up by the same amount. So this thing here, 2, 2, 2, 2, 2, that has a name, and that is called a common difference. The number that it's changing by each time is called a common difference. And that could be a negative number or it could be a positive number, but it's it's the same. Okay? So let's do one that is not changing by the same amount each time. What if I have numbers 1, 4, 9, 16, and then I wanted to know the next 2 numbers. You can tell me what the next 2 numbers are.
Whoa.
In there.
Wait.
You could try to find the common difference, but if you do, it's probably not the same. Come on, someone's going to figure this out. Think you have it, Jordan?
No.
Go ahead, look good.
Does it, the next number be 22?
No.
I know the first three.
What? You don't know? What? How'd you do that?
Because it's like 4 and then 5.
3, then 5, then
7.
7. Oh, that might be a way to look at it. Right, it's changing by 3, then 5, then 7, right? So what would be next?
25.
Yeah, then if it changes by 9, right? Then be 25, and what would be the next one?
34.
Right? Changing by 11, so what would be next?
Oh, 36.
36. But there's an easier way to do it, right? Don't those numbers look familiar to anybody?
No.
Not prime numbers.
Well, technically they are.
Very good, Sarah. Square numbers, right? 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16,
Yeah, like we would.
5 times 5 is 25, 6 times 6 is 36, right? So, so sometimes I'll say find the nth term, and so the number over here is n. So this is the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. So the nth term is going to be n to the second power, or just n squared, okay? But we're not going to kind of really talk about finding the nth term in that way, okay? Let's see if you can do, see if you guys can get this one. I need a new sheet of paper. 3, who's going to get it? 3, 9, 27, 81, or, wait, raise your hands if you think you have it.
N times 3.
Go ahead, Nick. Yeah.
Square. Yeah, square it.
Go ahead, Justin.
You multiply the preceding number by 3.
Very nice, okay? So what he said, so sometimes instead of adding something, you're multiplying something, right? So he said it's times 3, times 3, times 3. So what's 81 times 3? That's kind of hard to do in your head, right? Anyone know what that is? Nice, 243. 243, I don't know what that is. Did you do that in your head? You should be a math teacher. Okay, 729. All right. Okay, very nice. So that's how you do that. How about this one? We're gonna give them points with Swindon, right? Because they're being really good participants.
I have nothing to subtract. Who should I mark?
What?
Who should I mark?
We'll get there. Lizzie,
Okay.
Jordan, Justin, Catherine, Nick, Blake, Sarah. Okay. Okay. Oh. Jason's got his hand up. Go ahead.
It's the number times its negative self.
Almost. That.
Negative 2.
Good. Right. And the time's negative 2. So what do you get? What's next?
32.
2 times 6. Positive 32. What comes next?
Negative 64.
Negative 64. Nice. Okay. So this one is
Negative
talking.
64.
Right. I knew that. I was just seeing if you were paying attention. Okay.
No.
Negative 64. So we're multiplying by negative 2. Okay. That means times by negative 2. That's kind of x minus 2. You're multiplying by negative 2. Multiply by negative 2. That's, by the way, why when you get to algebra, they start using this as a time sign, or sometimes they use a star as a time sign, so you don't get it confused with x. But basically, I'm multiplying by negative 2. Very nice. All right. So you will be looking for patterns in your homework. So now we're going to talk just about arithmetic sequences, okay? And this is the last thing. And I know it sounds like a big word.
Arithmetic?
Is it arithmetic? It's a little bit different than arithmetic. Arithmetic means, okay, arithmetic sequence. And a sequence is any number pattern. Okay, we've been looking at sequences. Okay, so it's any number pattern. So an arithmetic sequence is one that changes by addition or subtraction. That's all it is. Okay, addition or subtraction.
So you can only add or subtract?
You can only add. So that last one that we did with multiplying, that's called the geometric sequence, and you'll worry about that when you get to algebra 2. But you will have some in your homework where you say you're just looking for the pattern. But as far as the formula, we're just worried about arithmetic sequences. Okay? And in an arithmetic sequence, it looks like A of n equals A plus n minus 1 times b. Okay? And what does this mean? This means this is the first term. This is called the term number, and this is called the common difference. Common difference. Difference. And this is the actual term. This is the nth term. So now we're kind of talking about things kind of in terms of algebra. The nth term, the first term, the term number, the common difference. I'll show you this, the way this works, okay? So they will do something like for A of n equals 5 plus n minus 1 times 3. That means times, there's a times sign. Find the first 5 terms. It's very algebraic looking, but it's really easy to do. Okay? Watch. Find the first 5 terms. What's the first term? Look up here. A, right? The first term is the thing that comes out front. So the first term is 5. And then you don't even have to plug into this formula because this is the common difference. So if it's going up by 3, what will be the next term? What's 5 plus 3? 8. What will be the next term? Huh? 11. What will be the next term? 14. What will be the next term? 17. Now this is where the formula is useful. What if they say find the 100th term? Well, obviously you don't want to count up. So when I talk about terms, it's like this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term, okay? So the fifth term is 17. The fourth term is 14. The third term is 11. to find the 100th term, go ahead, Jordan.
Wait, how did you get the 5, 8, 11,
Okay, so this is the common difference, right? So in the arithmetic sequence, one that changes by addition or subtraction. So if 3 is the common difference here, right? That means it's going up by 3 each time. See? So I have 5 plus 3 gives me 8.
and then 2 is the 5 from the beginning of the...
Yeah, because this is the first term, right?
Oh,
So
okay.
5 is the first term, 3 is the difference, and I'm not going to worry about this right now, okay? And so I just keep adding 3, plus 3, plus 3, plus 3, plus 3. But if I want the 100th term, that's where the formula is very useful. So what I do, because I don't want to count up until I get to 100, right? That's going to take me way too long. So what I want to do is use a formula, and when you get to Algebra 2, you'll learn about how you find the formula. And tonight's homework, they just give you the formula. All you do is you plug in 100 into the formula. So for this term, to find, so that would be A of 100. Okay, this is called function notation. A of 100 equals 5 plus n minus 1. Well, in this case, n is 100. Okay, so I'm going to plug in 100 for n minus 1 times 3. So now I just have to do the math. Okay? So I get 5 plus, what's 100 minus 1? 99. So 99 times 3, anyone know? It's 3 less than 300. 297. Okay? Because this is 99, right? And I know that 99 times, I know that 100 times 3 is 100. So anyway, so this comes out to be 302. So if I were to count up the terms until I get to the 100th term, I would get 302. Okay? And that formula would work for any of these. If I took 4 and plugged it in here, I would get out 14. If I plug in 3, I'd get out 11. If I plug in 1, what do I get out if I plug in 1 in here? What's 1 minus 1? 0 times 3 is 0 plus 5 is? What's 0 plus 5? 5. So the first term is 5. See the way that works? Okay, yes ma'am.
How did you get the 297?
100 minus 1 is 99, and I multiply 99 times 3. Because parentheses means multiply. Okay, one more practice problem, and then I'll let you go. Okay, say I have, I'm going to make up my own. So, say you have a sub n equals negative 3 plus n minus 1 times negative 2. Okay? And I say find the 8th term. Okay? All you have to do is plug in 8 into the formula. Right? So, plug in 8. Who wants to tell me what the answer is? You guys do it. I'm going to follow this. Okay? So, like I said correctly, the answer is negative 17. And all you have to do, so this is like A of 8 equals negative 3. You just plug in 8 in here. 8 minus 1 times negative 2. So follow your order of operations. You get negative 3 plus 8 minus 1 is 7. So it's 7 times negative 2. You do the multiplication first. So you get negative 3 minus 14, because it's plus minus 14, which gives you negative 17. Now if I want to list all my terms, okay, if I wanted to count, it would take me a lot longer, but I could find the the first 8 terms. The first term is right here, guys. So if I want to list this sequence, so here is the term, and here is n equals. That's the term number. So if I had 1, 2, 3, if I want to do this the long way, 4, 5, 6, 7, 8, which I don't want to, the first number is -3. The common difference is -2, so I'm taking away 2 each time. So what would be next? If I take away 2 from -3. -5. Then what? Negative. Take away 2.
Oh.
-7. -9. -11. -13. -15. -17, which is what we got up here. But who wants to do that, right? You don't want to count all the way up. You want to just say, what if I want the 100th term? I don't want to count up to 100, right? You want to just do it that way. So that's it. I'm done. And remember, you heard it here on Mr. Leader's YouTube channel. And, okay. So your homework is, we're going to stop.